What teams are represented by the baseball hats hanging from my wall?
Dodgers, Nationals, Red Sox, Astros, Cubs, and Royals.
I cannot wait to show you this. I just had lunch. I was a little bit sleepy, but I cannot wait to just show you the code that I built here for you. So if you remember, 3-4 weeks ago, OpenAI showed an assistant running on a phone. And that was kind of like magic in many, many different ways, because now you have a model that's actually interacting with the world, because the model has access to the camera of the phone and is seeing, or at least just to be more accurate, is processing the images that are coming through the cam on the phone and is using that as context to answer the questions from the people who were presenting that demo. So I asked myself one question: how hard could it be? All right. So what I want to show you today is a quick demo I put together, not as sophisticated, obviously, as what a multiple billion-dollar company did, but it's just a quick demo, very, very short, of doing the same thing with the webcam running on your computer, or that your computer has, okay? There are only 169 lines of code here. So this is short, and I'm only using here Python. I'm not using any external services. I'm using Python and the APIs, obviously, to, an API like a large language model. I'm using Gemini Flash here. I'm gonna explain why. I'm using the OpenAI text-to-speech API. Everything else is just a Python library. I am planning to rebuild this whole thing using services that are going to make my life way easier, but that's gonna come later. For now, I'll show you the code of how I built this assistant, and then we're gonna see a demo. I'm gonna run a demo here live with this assistant, and I hope you look at this and this inspire you. I posted about this on Twitter, and somebody told me that, hey, somebody's gonna grab your code and raise $1 million and go and build something. I hope somebody does that. Just remember me when you make it, okay? Just, kick me $5 or something. Kidding aside, let's take a look at the code. Again, 160 lines of code. How hard could this be? All right, so just a single file. It's called assistant.py. You are going to get access to this code through a link that I'm gonna post somewhere under this video, in the description of this video. While you're there, just give me a like or like this video. So I know the algorithm is gonna tell me, dude, listen, this type of content works for your audience. Keep making more. So just leave me that like, and let's look at the code here. I have, together with this assistant.py, just a single file, a requirements.txt file listing all of the libraries that I'm using here. And here are the main components. So gonna be 4 main components that I'm using to build this assistant. The first component is capturing the audio that's coming through my microphone and transcribing that, okay? And for that transcription, I'm gonna be using Whisper. So basically, it's capturing the stream of audio, transcribing it, and getting text. The second component is capturing the image that's presented here, or that's coming through my webcam. And I'm gonna be using OpenCV to do that. OpenCV is a very popular library, especially for people doing computer vision. Got all sort of functionality to deal with images. That's what I'm using to capture video. So now I have images, now I have video. Third component is a large language model. So for large language model, I'm using right now Gemini Flash 1.5. That's Google's model. I also left the code ready. So if you wanted to use GPT-4o, you can use GPT-4o, but I don't like it for this because it's way slower compared to Gemini. And for some reason I do not understand, it's less accurate at following my prompt. So anyway, we're gonna get there in a second. That will be the third component. So with images and text, I can send them to a model, like a multimodal model. So it has to support images and text. I'm gonna get an answer back, and now I need to synthesize that answer, like that text, into audio and play it through the speakers. And that is the fourth component. And to do that, I'm using the OpenAI text-to-speech API to do that. All right, so all of those things are gonna come here together to just create something that feels very magic, something that feels alive, right? It feels like it's just looking, right? By the way, I heard from people, this is apparently a misconception, that they think that the OpenAI model now supports video, okay? Like the GPT-4o supports video, because that's the impression you get when you watch one of these demos. No, it doesn't support video. What you're doing is just passing images, right? So a video is just a collection of frames. If you have a 24 frames per second video, you have 24 frames within a second. So for every second of video, you have 24 images. So what the model is actually doing is just processing images. The application, the glue, the wrapper around that model is what makes everything feels magic, right? Because it combines all of those components, right? The audio coming from the user, transcribing that audio, the images coming from the webcam or from the cell phone camera, and just grabbing frames from those videos, putting them together, answering those questions or processing that with a model, and then playing the answers back. All of those components together make this assistant feel magic, feel alive in a certain way. It's not that the model is any different to what it was before. That being said, here are the requirements. You're gonna have to install those. I have a README file that tells you what to do. One thing to notice, depending on whether you're using GPT-4o or Gemini, you are going to have to grab a key and create an environment variable with that key. My code is gonna rely on those keys for it to run. So you can actually access the large language model. Everything else is pretty straightforward. And this is how, actually I'm just using Python 3, so I'm gonna type it there. This is how you run the assistant. We're gonna see that in a second. Let's go to the code. And I want to start my code by explaining the first class that I created, which is called Webcam Stream, okay? I'm gonna try to go as fast as possible here, but Webcam Stream is a class that's gonna execute a thread to start capturing frames from my webcam. So in order to do that, I'm gonna be using the video capture class from OpenCV. Video capture, I'm gonna pass the index of the camera. In one computer, you might have multiple sources of video. Like right here in my computer, I have the webcam that's here on my computer. Sometimes I connect an external webcam, that will be a second source. The continuity camera from my phone, that's a third source, etc. I'm gonna be using here index 0. At this point, I don't have anything connected here. That will be, actually, I have my computer connected. I don't need this cable. Let me just move it away. At this point, index 0 represents my webcam here. Cool. So this here is just gonna give me access to a stream of images. And if I call the read function, that gives me back a frame. So just basically an image. And what this class is going to do is going to repeatedly on a thread start capturing those images. Okay, and it's gonna grab one image and it's gonna update a variable, like an internal property of this class, with the latest image that it captured. Why do I do that? Because at the time that I finish asking a question to the assistant, at that moment, I wanna go and grab the latest image that came from my webcam. So that image should be ready at that point. I wanna go there and say, give me the latest image, and I'm gonna process it. I'm gonna use that image together with the prompt that I spoke through the microphone. So that is why this class is gonna start doing that on a thread in the background. And again, just going really, really quick here. I'm creating the stream. I'm reading the first image, so the first time when I execute this, or when I run this class, when I create an instance of this class, I'm gonna grab that frame. And then I'm gonna mark this as running equals false. You're gonna see why that's important. And I'm gonna create a lock. So a lock is gonna act like a traffic light to prevent other threads accessing data while I need to be locking that data. So whenever I'm gonna make a change, I'm gonna lock my data. I'm just gonna do the operation, and then I'm gonna unlock it so other different threads can access that data. You're gonna see that in a second. There is a start function. This start function, when I call it for my webcam stream class, is gonna start that background thread. So you're gonna see that I'm gonna say, all right, so if this is running, do nothing, just return. If it's not running, set it as running equals true, and then create that thread and start that thread. Notice that the target function of the thread is the update function. So that's another function that I have here. What I mean by this is when that thread starts, it's gonna call the update function. Look at what the update function is going to do now. It's going to run in an infinite loop. It's not infinite. It's gonna be while running equals true. So if the thread is running, it's gonna keep looping. And the loop grabs an image from the webcam. So this takes one frame, stores it in this frame variable, locks access to whatever is in here. So it's locking access. It's saying, hey, nothing should come and read now because I'm gonna be doing an operation. That operation is basically grabbing this variable and updating, using that variable, updating the self property. So the property of this class. That is the latest frame, right? So I'm locking access. So if somebody wants that latest frame, it's gonna have to wait until I finish doing this, right? And then I release the lock. So basically, okay, so if anybody waiting, you can now comment. That is what this update is doing. Remember, this is just gonna be doing that in the background constantly, updating the latest image from the webcam. Then there is a read function, which is the function that I'm gonna call whenever I need that latest image. So whenever I'm ready to use an image, I'm gonna say, hey, just read my instance of the webcam stream, just give me that image. I pass a property that says encode, and this property is going to, if it's true, it's going to return that image encoded in base 64. Why do I need that? Because in order for me to pass that image, to send that image to GPT-4o or Gemini Flash, I need to pass it in base 64 format, right? If you have a URL, if your image was on a URL, it was public on the web, you could send the URL and it will work. Those models are capable of processing a URL. In my case, I'm capturing the image right here on my computer. I don't have a URL. I'm gonna have to encode it in base 64 and send it in base 64. This is what's going to happen here. First of all, when I get in, I'm gonna lock access to the frame, to the self frame. So nobody, like at this point, if I'm reading, the update process won't be able to change what I'm reading, okay? Because I'm locking it. I'm saying, everyone else wait, let me make a copy of this image into this variable. I'm gonna make a copy of it, and now I'm gonna release the lock. So now if something else was going to update this, well, now you can. And after I have that frame, now I'm going to, if its encode is true, I'm going to encode it in base 64 and return it. If not, I'm just gonna return the frame. And then I have a stop function that it just stops the thread and joins it. So nothing fancy here. All right, so that is what this class is for. Again, at a high level, it just manages my webcam and it grabs images and has one image ready for me whenever I want to use it. Okay, that's what the webcam stream is. All right, so I'm gonna skip the assistant class for 1 second, just so you see what I'm doing or how I'm initializing the webcam stream. You can see it here, line 135. I'm just creating an instance and then calling start. So starting from this point on, my webcam is just capturing images, capturing one image after another. All right, so let's go back now to the assistant class, which is the second class that I have here. And that's pretty much it. Everything else is just a small function that represents the glue of all of this. This beautiful assistant class. First, is expecting a model. So I need to provide an instance of a model to this class. By the way, this assistant is using LangChain. Two main reasons for me to use LangChain. Reason number one, it makes my code way shorter. Like I don't have to deal with a lot of verbosity that comes from using the APIs directly. LangChain makes my code beautiful. It also makes my code composable, meaning I can put together different components. I can mix and match and just sort of like build this Lego application with different components. You're gonna see that in a second. That is beautiful. The second reason, I guess those were two. So this is the third reason why I'm using LangChain here, is because I can swap my model with another model. And I don't have to change a single thing here. So this class expects a model and nothing inside this class. You're gonna see how I put together the prompt, how I invoke a chain, etc. Nothing here depends on one specific model. So I can use Gemini Flash, or I can use GPT-4, or I could use any other model that's supported by LangChain, which is pretty much all the models out there, and everything, all of the details will be transparent to me. That is That is amazing. Again, goosebumps whenever I talk about that. All right, so my assistant is expecting a model. And as part of the initialization of this class, the constructor of this class, I'm just gonna call this function that's called create inference chain. So basically I'm gonna create a LangChain chain that does the inference. So let's take a look at that because that's where most of the good stuff happens, okay? So here is my function. I start that function with the system prompt. This is how I instruct the model about what it needs to do. It's the main configuration that that model is going to receive, the main set of instructions, okay? These instructions have nothing to do with the chat I'm going to have with the model. I'm gonna ask the model to read things and do stuff and look at my glasses and that type of cool things. This has nothing to do with that, okay? This is just a system prompt, the main prompt that how I'm gonna configure the model. I'm asking the model to be witty, to be concise, to go straight to the point. Interesting enough, GPT-4o does not like this system prompt. It is just chatty, okay? It just goes on and on and on and on all of the answers. For some reason, it just doesn't like to be concise. It doesn't like to be short. That is another advantage of Gemini Flash 1.5 for this application. Besides, Flash 1.5 is really, really fast compared to GPT-4o. So that's my system prompt. And now I'm gonna create a prompt template, okay? Let me actually close this. So the prompt template is the structure that I'm going to create with all of the messages that I'm gonna be giving the model to answer a question. So obviously the prompt template is going to contain the system prompt, and this is how you define that system message as part of the prompt template from LangChain. It's also going to have the chat history. So one important thing is I want this assistant to remember what we just talked about 3 questions before, right? I don't want the assistant to forget. I don't want every prompt, every question to start from scratch. So I'm gonna be enabling chat history. And you're gonna see in a second how I enable that. Not a big deal, but I'm gonna be passing the chat history. And finally, I'm gonna be passing my prompt, which is whatever I speak through the microphone, I'm gonna grab that, that's that text, I'm gonna pass it, and the image that I'm going to get from the webcam. So there are 2 things here. As the human message, you can see here, the definition here is human. The first thing is the prompt, which is type text. So I'm telling the model, hey, your prompt includes some text, and this is it. And this thing that you see here is just a variable, a prompt variable that we are gonna replace in a second with the real text. And the second thing, type, is just image URL in this case, and the URL of that image is just data :image /JPEG semicolon base64. That is the prefix that you have to add when you're passing a base64 image, and then a variable that contains the actual bytes of that image, the base64 conversion of that image. So I have 2 variables here that I'm gonna need to replace in this prompt. You're gonna see that in a second. Next line, 124, I'm going to compose my chain. And it's beautiful what LangChain did, allowing us to put all of these components together. Is syntax sugar, that's what it is. So I have my prompt. And basically what I'm doing is piping the output of my prompt into the model. That's what this pipe means. That's the symbol of pipe. So at the output of that prompt is gonna go into the input of the model, which is, again, I'm expecting a model. This class expects a model. I haven't created that yet. So whatever that model is, I'm gonna be connecting the output of the prompt into the model, and the output of the model, I'm gonna be sending to a string output parser. This is something that happens when you're using a chat model. The chat model is going to return, that's the way the LangChain chat or model representation works, is that it's going to contain, the conversation is going to be well delimited by who said what. So you're going to get things like human message, an AI message, and human message, and that sort of like back and forth. And I don't want any of that as part of my answer. I just want a straight answer. Just give me the text. So the string output parser is one of the supported parsers for you to change the output of a model or convert the output of the model into a specific format. In this case, it just converts it as a string. So if the model says 2 plus 2 is 4, I don't need AI, message, 2 plus 2 is 4. I don't need all of that mambo jambo. I just want the text. This is what I'm gonna get here. So that is what a chain is. It's just a bunch of components where one component pipes into the next one, etc., etc. So this is my chain. One more thing for this chain to work, and it's that chat history. I need to make sure that chat history is there. So LangChain offers a wrapper when you want to implement chat history. And in my case, it's just very simple. Like I'm not storing that chat history anywhere. I only want to keep one history. Like I don't need multiple histories or anything like that. So LangChain supports this runnable with message history wrapper where I can get my chain and take this runnable with message history wrapper and create an instance of it, passing the chain, and the result that I'm going to get is still a chain, but now supports chat history. So behind the scenes, LangChain is gonna do all of the work of grabbing the answer from the model, adding it to a list, grabbing my next request, adding it, happening that to that list, and keeping that history going. All of that is gonna happen behind the scenes. I just need to come here and create this class. Not gonna get into too many details. The most important thing here that you need to know is that this variable here, which is the history message key, this variable is the same as this variable. They have to be the same. So the prompt knows exactly where to get the chat history from, okay? And by the way, there are multiple ways of configuring chat history for LangChain. This is the simplest one that I wanted to use just for this demo. So that is that function. The return of this function is just the chain that I can invoke with the actual data. So whenever I'm ready to answer a question, I'm just gonna invoke that chain. Let's see how that works. I'm gonna go up. I'm still within the assistant class, and I have two more functions to go through. The first one is the main function that we're gonna call. That function is called answer. So I'm gonna ask a question, and I'm gonna call this function to tell the assistant, please answer this. This function receives the prompt, which is gonna be the text that I'm gonna be speaking through the microphone, and the image that my webcam is going to capture. I'm gonna pass both things, and this is what's gonna happen internally. First, if the prompt is empty, if for some reason I got no audio, whatever it is, I'm not just gonna return, not gonna do anything. I'm gonna print the prompt, so you're gonna see it in the terminal window, this is what I asked, and then I'm gonna invoke my chain. And when I invoke my chain, I need to provide values for the template variables. Remember, my template is expecting a prompt variable and the image base64 variable. So I need to invoke my chain with those two values. So here is the prompt and here is the image base64. I'm just calling decode because image is coming in as a byte array. So I need to decode that into a string so I can actually pass it here. That's what I'm calling the decode there. So here is those two parameters. And again, for the chat history to work, I need to offer like a session ID, which I'm not using, not gonna get into this. This is a LangChain thing. That's what the config is. In fact, I think I can get rid of this config and everything will work the same, probably. I can try that later. So, all right, so final thing that I'm doing is I'm stripping out any new line characters that come from the model. Like the model is gonna send me an answer and it's gonna come followed by a bunch of new line characters, just getting rid of those or any white spaces, so that's it. This is my response at this point. Beautiful. So I'm gonna print that response, and I'm actually gonna do something here. If that response is something, I'm just gonna play it. So by playing it, what I mean is I'm gonna call this text-to-speech function that I built, and that is gonna get the text, the response from the model, and it's gonna play it out through the speakers of my computer. So this is how that works. This text-to-speech function is going to be using PyAudio, which is one of the libraries that I'm installing here. PyAudio is gonna give me access to play sound through my speakers, okay? So I'm gonna just configure PyAudio, I'm gonna just open it. That's gonna give me what I'm calling a player. This is something that I can write bytes to, and those bytes are gonna be turned into sound that come out of my speakers. And this is the configuration. You can look more about that in the PyAudio library, not interesting. This here is me talking to this audio.speech with streaming response. I think here it is. That's ugly, actually. I'm gonna just get rid of this and I'm gonna add it here just so it's a little bit clearer what is happening. OpenAI.audio. Well, I'm gonna have to import now OpenAI, obviously. So this way is a little bit more clear where that function is coming from. So now I have, where was I? Here I am. So I'm gonna be calling the OpenAI.audio.speech with streaming response create. And this is basically behind the scenes calling the OpenAI streaming API. And when you call that API, you're gonna pass obviously the text and you can stream back the bytes that sound like a voice. Basically, you're synthesizing that text into audio. So here, this is the model that I'm using, the TTS1. TTS, if I haven't mentioned, is text to speech. That's what it means. The voice is Alloy. This is the API that previously had Sky. And I don't know if you're aware of all of the mambo-jambo drama with Scarlett voice, but now we don't have access to Sky. I have access to Alloy. So that's what this assistant is going to sound like. Response format, PCM, there are multiple formats that are supported. And the input, so the text is, I'm passing it here, is the response. I'm gonna grab that, that's the stream. And now I can just iterate through bytes and the size of the chunk. So I'm gonna be getting 1024 bytes or 1024 bytes at the time I'm playing them through the speakerphones, okay? And the way you just play that is just by writing to the player stream that I created with PyAudio. That's it, it's very simple, okay? Grab the audio here, the bytes of the audio, just play them, and that's it. What's left? Well, how you put together all of this? So we saw the webcam, we saw the model, we saw the audio. The only thing left is how do I capture this and how do you glue all of this together? And that is going to happen right here. Again, it's just a few lines of code. They fit on my screen almost. So we saw this line already. 136 creates the webcam. Remember, now I'm capturing images. Now this is me creating the model that I'm gonna be using. And as you can see here, I'm using the Chat Google Generative AI class, and I'm specifying I want Gemini 1.5 Flash latest. This is the model that I decided to use. But if you want to try with GPT-4o, here is how you do it. You uncomment that line, and now you have ChatGPT 4o. You don't have to change anything else. Goosebumps, not changing anything else. It's just going to work thanks to LangChain. All right, so assistant, I'm gonna create an instance of my assistant and I'm gonna pass the model, in this case, Flash. And now there is a function, we're gonna get to that function in a second. Here is the next line, I'm gonna be using a library that's called speech recognition. Beautiful library. It made these so much easier because speech recognition handles my microphone, captures the audio, listens in the background. I don't have to worry about any of that. And it gives me functionality to automatically transcribe my audio. I don't have to use Whisper myself, which is not a big deal, but if the library does it for me, even better. So let's see how I use that library. A couple of instances, a recognizer. The recognizer is the instance that's gonna allow me to just transcribe the audio using Whisper, and a microphone representing this beautiful thing that you have here, or that I have here in my face. I'm going to start my microphone by adjusting for ambient noise. I'm actually not quite sure what it does internally or how it adjusts for ambient noise. I'm assuming it does some math just to feel how much noise is in the room. I don't know, I'm guessing. I haven't looked into it too much, but here is just the main line here for the microphone. Recognizer.listen in background. That's it, just one line. Listen in background. That line right there is just going to enable this microphone to start capturing audio, or just the computer to start capturing audio from the microphone. No, the microphone is not doing anything. You're just transmitting the audio. So it's going to start grabbing the audio from the microphone. And as soon as it hears a stop, as soon as I stop talking, blabbling, however you want to call it, it's going to grab all of that and it's going to send it to this callback function, which I define right here. That's it. That is going to happen without me having to do anything else. Now, let's finish this code. While true, so repeat this forever, display an image in a window with the title webcam. That's what's happening here. And that image should be coming from the stream, the class that we created. Remember, we have that stream processing in the background. I want to display the images just so you sitting here in front of the computer, you actually see the webcam working and you know what you're doing and where you're pointing at. So this is going to happen thanks to this line. CV2, that is a reference to OpenCV. That's the alias of the library. Image show, IM show, that creates a window with this title, webcam, and then it displays this image here. That's it. So I'm going to do that. And then I'm going to be waiting for a key. If you press the key, that's either key 27, which references the escape key, or a Q, like a lowercase q, if you press any of those two keys, then I'm just going to break out of this loop. So whenever you run this assistant and that window shows up, you have to press either the escape key or the Q for that window to close. When you do that, when you close the window, I'm going to stop the thread that's capturing images. I'm going to destroy all open windows that were created by OpenCV, and I'm going to stop listening. So the class that's doing the listening in the background, I'm just going to stop listening. And notice that I'm saying waiting for a stop equals false, meaning even if you're speaking at that point, when you say just stop listening, it's just going to stop listening at that point. It's not going to wait for you to finish your sentence. It's just going to destroy it. All right. So one more thing, which is the glue here, is the audio callback function. So remember, that callback is going to execute whenever I ask something using my microphone. I'm going to ask, hey, how are you today? And as soon as I make a pause, the audio here, the library internally is going to grab all of that audio and it's going to say, stop right here, send that to the callback. So the callback internally, this is what I'm going to be doing here. First, I'm going to grab the audio, which again is coming here. What happened here? What happened? Okay. The audio is coming here and the recognizer, which is this instance. I'm going to use that recognizer and I'm going to call the function recognize whisper. That means recognize using Whisper. If you open the documentation of that library, they support a bunch of other libraries, okay? I'm using Whisper in this case. So I'm gonna pass the audio. I'm gonna say that I want the base model, which is fast enough. There is one that's even faster than the base model, I think. Maybe they have a tiny model or a small model, I don't remember, but there might be one that's even faster than the base model. And there are some models that are medium and large. They are way more accurate, but way slower. So I want the base model. The language that I'm gonna be speaking to is English. You can do a bunch of cool stuff, translating and whatnot, but not interesting right now. And this is going to return, it's gonna grab that audio and it's gonna give me text, because I need text to send to my assistant. And that is the next thing that I'm going to do. I'm going to call the answer function that we already talked about. I'm going to pass the text and I'm going to pass the latest image that I captured from my webcam. And in this particular case, I'm saying encode true, meaning give me a base 64 of that image. That's it. That is the whole magic of this application here. Now let me run it here. Just so you see it working. The first time when I ask the first question, it's gonna take a little bit of time. So it's warming up. For the second and third and fourth question, it's gonna go faster. I'm gonna run this by doing Python 3 assistant.py. So I'm gonna do that. What color are my glasses?
Black.
What teams are represented by the baseball hats hanging from my wall?
Dodgers, Nationals, Red Sox, Astros, Cubs, and Royals.
What is the title of this book?
Human in the Loop Machine Learning.
Who's the author?
Robert Monroe Monarch.
All right, so that was pretty good. It works, as you can see, it's fast enough. I mean, it's not lightning fast, but it's fast enough for this to be a little bit useful. A couple of things that I wanted to mention are ways, in case you want to run this on your computer, ways that you can, in which you can improve this. So number one, you should be able to implement a way for you to interrupt the assistant. That's something that OpenAI mentioned a bunch of times as part of their demo. You should be able to do the same. It shouldn't be too hard. You just need a flag somewhere, and as you're playing audio back in this function here, the TTS function, as you're playing audio back, you might be able to just make sure that flag is not set. And if it is set, you interrupt. That's if the user starts speaking again, you interrupt this processing. That's gonna make it a little bit more dynamic. So that's one thing. Number two, you need to make sure you make the application a little bit more robust. Like sometimes the OpenAI API might fail, or maybe Gemini is not working. So make it a little bit more robust. And the third idea that I think is a pretty good one is about streaming answers from the model back. Like right now, I'm using Invoke here. And what's going to happen is I'm sending the API, the text and the image, and I'm waiting for an answer to come back, okay? If that answer happens to be a long answer, I'm gonna have to wait for the model to generate the entire answer before I start playing that through the speakers. So a way to improve that would be to stream the answer from the model back, so I don't have to wait until the entire answer is generated. I can start playing audio as the assistant is generating the answer. That would be ideal. I think just by doing those three things, this is going to feel much more realistic in a way, right? Obviously, playing with the system prompt is important as well, just to get it behave as you want it to behave. Maybe make it a little bit more flirty, like OpenAI clearly did, or whatever you decide. Anyway, I hope this is helpful. This kind of stuff is really fun to build. If you really like that type of content or this type of content, please either subscribe or like this video so the algorithm lets me know that you like this type of content. Enjoy it, and I'll see you in the next one. Bye-bye.